Hello, and welcome back to Automate Office Work. I'm your host, Justin. Today's episode is Thinking Like a Programmer. So, I imagine that many of you are not yet programmers, and you might find it a little bit scary to jump in and to learn a coding language, but you might be surprised to find out that coding is not the most important part for automating. Actually, we need more people who have the programmer's mindset, the ability to look at a situation and break it down into its individual parts, which you can then convey to someone like myself, to someone who is a programmer. So it's more important to get the mindset. And to get this mindset, I have written a book called Thinking Like a Programmer, which you can find on my website, automateofficework.com. You can either click on the resources link at the top, or you can scroll down to the resources section. And one of the resources is Thinking Like a Programmer. It says this book helps you get the programmer's mindset with none of the coding. Click on there and you can find this book in several formats. You can find it broken down into individual audio files of me reading each section of the book to you, or you can click on the YouTube and find the individual videos of me reading these different parts of the book. You can also click on a link to purchase this book in print on Amazon, or you can click on each individual section's link and you can read along. So I will be reading this to you today. It's a very short book. It only takes about 40 minutes, but it gives you the mindset of thinking like a programmer so that you know the concepts instead of an actual coding language, which you do not need. Which, of course, I would also encourage you, by all means, do go learn coding languages. But you'll also find as you learn a couple of coding languages that the concepts behind them are the same, no matter which language you're learning. And it can be very helpful working with teams to get them to also be thinking in terms of like programming concepts so that they can be much more helpful in the process of automating their work. All right. So I will read this book to you very quickly. Introduction. Why think like a programmer? Programming is often thought of as a highly technical skill reserved for those fluent in writing lines of code. However, thinking like a programmer goes far beyond syntax and software. It is a way of approaching problems with clarity, creativity, and logic. This mindset, often called computational thinking, holds immense value not just for developers, but for anyone seeking to navigate the complexities of modern life. By understanding the principles behind how programmers think, you can transform your approach to challenges, decisions, and even personal goals. The importance of understanding computational thinking. At its core, computational thinking is a problem solving methodology that borrows from the practices of computer science. It involves breaking down complex problems into smaller, manageable parts, identifying patterns, and devising step by step strategies to reach a solution. These skills are essential in programming, where ambiguity is the enemy and precision is critical. But they are just as useful in other areas of life, from organizing a project to troubleshooting a household issue. Consider, for example, planning a family vacation. The task can feel overwhelming, choosing a destination, setting a budget, booking accommodations, and coordinating activities. A computational thinker would start by breaking this large problem into smaller tasks, addressing each in turn. They might identify patterns in past trips to predict potential issues and apply a systematic approach to optimize costs and schedules. By thinking like a programmer, they reduce stress and ensure no detail is overlooked. In an era of increasing complexity where decisions often involve competing priorities and incomplete information, computational thinking provides a framework to navigate uncertainty. It encourages clear analysis, logical reasoning, and adaptability, qualities that benefit everyone, regardless of their familiarity with technology. Improving problem solving in everyday life. The ability to think like a programmer can make a profound difference in how you solve problems, big or small. One hallmark of this mindset is the emphasis on understanding the root cause of an issue before attempting a solution. Programmers often learn early on that patching a symptom without addressing the underlying problem leads to recurring errors. The same principle applies in everyday situations. Fixing a flat tire is one thing, but identifying why the tire keeps deflating ensures the problem won't return. Another key aspect of this approach is abstraction, the ability to focus on what is essential while setting aside irrelevant details. For example, when learning a new recipe, you don't need to know the chemistry behind every ingredient. Instead, you focus on the sequence of steps that leads to a successful dish. This ability to prioritize and simplify can help you make better decisions, save time, and avoid unnecessary frustration. Lastly, computational thinking emphasizes iteration, the process of testing, refining, and improving a solution over time. Programmers rarely get things perfect on the first try, and neither do the rest of us. Embracing this mindset helps you view mistakes as opportunities to learn and grow rather than as failures. A preview of the book's approach. The goal of this book is to introduce you to the principles of computational thinking without diving into the technicalities of coding. While programming languages are valuable tools, the concepts behind them are what truly empower problem solving. By focusing on these concepts, this book offers an accessible entry point for anyone, whether you're a student, a professional, or someone simply curious about new ways of thinking. Each chapter will explore a key aspect of computational thinking, from breaking down problems into smaller parts to recognizing patterns and designing efficient solutions. You'll find relatable examples drawn from everyday life to help you see how these principles apply beyond the screen. There's no prerequisite knowledge required, just an open mind and a willingness to think differently. By the end of this book, you'll have a deeper appreciation for the mindset that drives programmers and a toolkit of strategies to approach challenges in smarter, more effective ways. Whether you're tackling a tricky work problem, learning a new skill, or just organizing your day, thinking like a programmer can help you unlock new levels of insight and creativity. The journey begins here, not with code, but with concepts. Part 1, Foundations of Computational Thinking. Chapter 1, The Programmer's Mindset. Programming is more than just writing code. It is a way of thinking about problems and solutions. The programmer's mindset involves breaking problems into smaller, manageable parts, embracing trial and error as a method for discovery, and thinking logically and systematically. These principles form the foundation of computational thinking and are essential for tackling challenges both in programming and in everyday life. Breaking problems into smaller, manageable parts. One of the first things a programmer learns is how to decompose a problem into smaller components. This process, often called problem decomposition, is critical because it makes complex tasks less daunting. For instance, consider the challenge of organizing a large event. Instead of viewing it as one overwhelming task, you can break it down into smaller steps. Choosing a venue, sending invitations, arranging catering, and planning activities. Tackling each piece separately reduces stress and ensures nothing is overlooked. Programmers apply this same principle when writing software. A large program is divided into modules or functions, each responsible for a specific task. By addressing one module at a time, they build solutions piece by piece. This approach not only makes the process manageable, but also allows for flexibility and focus on individual components. Embracing trial and error, the power of iteration. Trial and error is an inherent part of problem solving, and programmers understand this better than most. Rarely does a piece of code work perfectly on the first attempt. Debugging, testing, and refining are integral to the process. Iteration, the act of revising and improving, allows programmers to learn from mistakes and create better solutions over time. This principle is equally relevant outside of programming. Consider learning to bake a new type of bread. The first attempt might yield less than perfect results, but each subsequent try allows for adjustments, perhaps tweaking the temperature, proofing time, or ingredient ratios. Iteration is not failure, it is progress in disguise. Embracing this mindset fosters resilience and a willingness to explore creative solutions. Thinking logically and systematically. Logical thinking is at the heart of computational thinking. Programmers rely on clear, step-by-step reasoning to design solutions and anticipate potential issues. This systematic approach minimizes errors and ensures solutions are efficient and effective. In everyday life, thinking logically can help with decisions as simple as planning a route to work, systematically comparing options, factoring in distance, traffic, and time constraints. you can determine the best choice. Logical thinking is a skill that improves with practice, making it easier to navigate complex situations with confidence. Chapter 2: Algorithms in Everyday Life. What is an algorithm and why does it matter? An algorithm is a sequence of steps designed to accomplish a specific task. In programming, algorithms are the building blocks of functionality, but algorithms are not limited to the digital world. They are everywhere. From following a recipe to assembling furniture, we use algorithms daily, often without realizing it. Understanding algorithms allows us to approach tasks more methodically. For example, following a recipe involves a series of precise steps: measuring ingredients, mixing them in a specific order, and cooking for a designated time. Skipping steps or altering the sequence can lead to unintended results. Recognizing this process as an algorithm helps us appreciate the importance of structure and order. Real world examples: recipes, driving directions, and decision making. Recipes are a straightforward example of algorithms in action, but driving directions are another. Navigation apps use algorithms to calculate the fastest or most efficient route to a destination. Consider variables, Considering variables like traffic and road conditions. By following these step-by-step instructions, we reach our goals efficiently. Algorithms also play a role in decision making. Imagine deciding where to eat. You might consider factors such as proximity, price, and reviews, applying a step by step process to narrow down your options. This systematic approach mirrors how computers process data to reach conclusions. Chapter 3: Abstraction. Seeing the forest, not just the trees. Abstraction is the art of focusing on the essential details while ignoring the irrelevant ones. It is a cornerstone of computational thinking, allowing us to simplify complexity and solve problems more efficiently. Simplifying complexity by focusing on the essentials. A map is a perfect example of abstraction. It doesn't depict every tree or building. Instead, it highlights the critical features necessary for navigation. Similarly, when summarizing a book, we focus on key themes and events rather than recounting every detail. Abstraction helps us process information efficiently and prioritize what truly matters. Real world abstraction, using maps, categories, and summaries. In everyday life, abstraction is invaluable. When categorizing expenses, for instance, grouping them into broad categories like food, transportation, and entertainment simplifies budgeting. Summarizing meeting notes into actionable points ensures clarity and focus. Abstraction enables us to handle complexity without being overwhelmed. Chapter 4: Patterns and Reuse. Recognizing and leveraging patterns to solve new problems. Patterns are recurring elements that simplify problem solving. Programmers often encounter similar challenges across projects and develop reusable solutions, such as design patterns. By recognizing these patterns, they save time and effort. In life, recognizing patterns is equally powerful. For instance, if you've successfully negotiated a discount in one situation, you can apply similar tactics in the future. Patterns provide a framework for approaching new challenges with confidence. Examples from life: reusing solutions in similar situations. Think about packing for a trip. If you've developed a checklist for a weekend getaway, you can adapt it for a longer vacation by adding or removing items. This reuse of a proven solution streamlines preparation. Similarly, troubleshooting a recurring issue with a household appliance often involves identifying a familiar pattern and applying a known fix. Recognizing and reusing patterns helps us navigate life more efficiently. By building on past successes, we create a toolkit of strategies that make solving new problems less daunting. Through these foundational concepts, computational thinking offers a practical and powerful way to approach challenges in programming and beyond. The journey into this mindset begins with understanding these principles and recognizing their relevance in everyday life. Part 2: Problem Solving Tools and Strategies. Chapter 5: Decomposition. Breaking down problems. One of the most effective tools for tackling complex problems is decomposition, the process of breaking a larger task into smaller, more manageable steps. This strategy allows you to focus on one piece at a time, reducing overwhelm and making it easier to identify potential solutions. Decomposition is not just for programmers, it's a universal skill that can be applied in any domain. How to divide complex tasks into smaller steps. Decomposing a problem begins with identifying the overall goal and then dividing it into subtasks. For example, if your goal is to renovate a room, you might break it into steps such as budgeting, selecting materials, hiring contractors, and managing the timeline. Each subtask can then be addressed individually, allowing you to make steady progress. A key to effective decomposition is prioritization. Determine which subtasks need to be completed first and how they relate to one another. Some tasks may be dependent on others. For example, painting cannot begin until repairs are complete. By organizing these steps logically, you create a clear roadmap to follow. Exercises to practice decomposition in real life. Number one, organizing a party. Listing everything needed for List everything needed for the event, such as invitations, food, decorations, and entertainment. Break each item into actionable steps. For example, for food, decide on the menu, shop for ingredients, and prepare dishes. Number two, planning a vacation. Divide the process into subtasks like choosing a destination, booking transportation and accommodation, creating an itinerary, and packing. Address each component systematically to avoid last-minute stress. Practicing decomposition with everyday tasks strengthens your ability to handle complexity and approach challenges with confidence. Chapter 6, Thinking in Steps, Sequencing. Sequencing is the foundation of logical problem solving. It involves arranging tasks or actions in the correct order to achieve a desired outcome. In programming, this concept is essential, as computers execute instructions exactly as written. In life, improper sequencing can lead to inefficiencies and errors. Why order matters in problem solving. The sequence of steps often determines success or failure. Consider baking a cake. Mixing ingredients before preheating the oven won't harm the process, but skipping the step of adding baking powder can ruin the entire effort. Similarly, when assembling furniture, following the instructions out of order can result in frustration and a wobbly final product. Sequencing also applies to decision making. For example, when planning a project, you need to conduct research before creating a strategy and executing tasks. Skipping research may lead to uninformed decisions and wasted effort. Thinking in steps ensures that each action builds on the previous one. Flowcharts and decision trees as visual aids. Visual aids like flowcharts and decision trees are invaluable for sequencing complex tasks. A flowchart uses symbols and arrows to map out a process step by step, while a decision tree helps you explore multiple outcomes based on different choices. For instance, a flowchart for meal preparation might outline steps such as choose a recipe, gather ingredients, cook, and serve. A decision tree for career planning might start with identify interests, branching into pursue education, or seek work experience. These tools provide clarity and help you visualize dependencies and outcomes. Chapter 7, Decision Making, Conditionals. Decision making often involves evaluating conditions and determining the appropriate course of action. In computational thinking, conditionals take the form of if then else statements, which guide logical decisions based on specific criteria. This framework is just as applicable in everyday choices as it is in programming. How if then else thinking applies to everyday choices. Conditionals help us weigh options and make decisions efficiently. For instance, imagine you're deciding whether to go for a walk. You might think, if it's sunny, then I'll go outside. Else, I'll stay in and read. By evaluating the condition, weather, and its outcomes, you streamline the decision-making process. This approach is useful for more complex decisions as well. Consider buying a new car. If the car fits my budget and meets my needs, then I'll purchase it. Else, I'll keep looking. Framing decisions in conditional terms clarifies your priorities and simplifies the evaluation process. Examples of conditionals in decision making. Budgeting. If I save 20% of my income, then I can afford a vacation. Else, I'll wait another month. Time management. If I finish my work early, then I'll have time for a workout. Else, I'll prioritize rest. By incorporating conditionals into your thinking, you can approach decisions systematically and make choices with confidence. Chapter 8: Loops, when repetition is key. Many tasks in life involve repetition. From brushing your teeth daily to practicing a skill, repetition builds habits and reinforces learning. In programming, loops are used to automate repetitive actions. Understanding how to recognize and optimize repetitive tasks can save time and energy. Recognizing repetitive tasks and automating them. Identifying repetitive tasks is the first step toward improving efficiency. For example, if you find yourself manually sending the same email to multiple people, you might use an email template or automation tool. Similarly, if grocery shopping involves buying the same staples every week, creating a reusable list can streamline the process. Automation isn't limited to technology. Personal routines can be optimized as well. For instance, preparing meals in bulk reduces the need to cook every day, freeing up time for other activities. Recognizing patterns in your tasks allows you to design more efficient workflows. Examples: daily routines, fitness goals, and scheduling. Daily routines. Establishing a morning routine, such as waking up, exercising, and preparing breakfast, eliminates the need to decide each step every day. Fitness goals. Training for a marathon involves repeating running exercises with gradual increases in intensity. This structured repetition builds endurance and confidence. Scheduling. Setting recurring reminders for bills, meetings, or chores ensures that important tasks are never forgotten. By leveraging the power of loops in your daily life, you can handle repetitive tasks more effectively and focus your energy on what matters most. Mastering these tools and strategies, decomposition, sequencing, conditionals, and loops, equips you with a versatile problem solving toolkit. Whether tackling personal challenges or professional projects, these principles will help you think more systematically and achieve your goals with greater ease. Part 3: Thinking in Systems. Chapter 9: Inputs and Outputs. Understanding how systems work begins with recognizing their inputs and outputs. Inputs are the resources, data, or actions that initiate a process, while outputs are the results or responses generated by the system. By examining these components, we can gain insight into the functionality and efficiency of any system, from simple machines to complex organizations. Understanding how systems work by examining inputs and outputs. Every system relies on inputs to produce outputs. In its simplest form, a system can be thought of as a transformation mechanism. Inputs go in, get processed, and outputs come out. For instance, consider a coffee machine. The inputs are coffee grounds, water, and electricity. The output is a freshly brewed cup of coffee. Understanding the relationship between inputs and outputs helps identify inefficiencies and opportunities for improvement within the system. This principle is equally applicable to non-physical systems. In customer service, for example, inputs might include a customer's complaint, the service representative's training, and the tools they use to resolve issues. The output is the customer's satisfaction or resolution of their problem. By analyzing these elements, businesses can refine their processes to improve outcomes. Examples: thermostats, websites, and customer service processes. A thermostat is a classic example of an input-output system. The input is the current room temperature measured by a sensor. The thermostat processes this information, compares it to the desired temperature, set point, and generates an output, turning the heating on or cooling system on or off. This straightforward system showcases the importance of clear and accurate inputs to achieve reliable outputs. Websites function similarly. When you visit a website, your browser sends inputs, such as HTTP requests, to a server. The server processes these requests and delivers outputs in the form of web pages. The quality and speed of the outputs depend on the efficiency of the inputs and processing systems. In customer service, the process begins with a customer's inquiry, input, which is handled by representatives using scripts, training, and technology processing. The final resolution or feedback provided to the customer constitutes the output. Analyzing these elements enables organizations to optimize both efficiency and customer satisfaction. Chapter 10, Feedback Loops. Feedback loops are essential for learning and growth within systems. They involve using the results of a process to inform and adjust future actions. Understanding how feedback works, whether in positive or negative, allows systems to evolve and improve over time. Learning from results, positive and negative feedback in systems. Feedback loops can be categorized into two types, positive and negative. Positive feedback reinforces a process or behavior, amplifying its effects. For example, praise for good performance encourages continued excellence. Negative feedback, on the other hand, highlights errors or deficiencies, prompting corrective action. Both types are vital for maintaining balance and driving improvement. In a heating system, for instance, negative feedback ensures stability. If the room temperature exceeds the desired set point, the thermostat signals the system to stop heating. Conversely, in personal growth, positive feedback, such as achieving milestones, motivates individuals to persist in their efforts. Real world examples: learning a skill, budgeting, and dieting. When learning a new skill, feedback loops are crucial. Imagine practicing a musical instrument. Positive feedback comes in the form of mastering a piece or receiving compliments, while negative feedback includes noticing mistakes or struggling with a section. Both guide adjustments, such as refining techniques or dedicating more practice to challenging areas. Budgeting also relies on feedback. Tracking expenses, input, reveals patterns that inform future decisions. Overspending in one category serves as negative feedback, prompting tighter control, while staying under budget provides positive reinforcement to maintain good habits. Dieting is another example. Weight loss or improved health metrics provide positive feedback, encouraging continued adherence to the plan. Conversely, weight gain or fatigue might signal the need for adjustments. By paying attention to feedback, individuals can fine tune their approach for better results. Chapter 11, Error Handling and Resilience. No system is perfect. Errors and unexpected situations are inevitable, but how a system handles these challenges determines its resilience. Programmers approach errors methodically, aiming to identify, mitigate, and learn from them. These principles are equally valuable in everyday life. How programmers deal with mistakes and unexpected situations. Programmers anticipate errors by incorporating error handling mechanisms into their code. These mechanisms include validations, exceptions, and fallback options. For example, if a program expects numerical input but receives text, it might display an error message and prompt the user to correct the input instead of crashing. Error handling also involves debugging, the process of identifying and fixing the root cause of a problem. Debugging is systematic. Programmers analyze logs, test scenarios, and trace code execution to pinpoint issues. This proactive approach minimizes downtime and prevents similar errors from recurring. Learning to fail gracefully and adapt. In life, embracing error handling means acknowledging that mistakes happen and preparing to address them constructively. For instance, if a travel plan is disrupted by a flight cancellation, having a contingency plan, such as rebooking options, can turn a stressful situation into a manageable one. Resilience is about remaining flexible and resourceful in the face of setbacks. Failing gracefully also involves learning from mistakes, reflecting on what went wrong and how it can be prevented in the future, transforms failures into valuable lessons. This mindset encourages growth and fosters a sense of empowerment. Building resilient systems. Resilient systems are those that can recover quickly from disruptions and continue functioning. Whether it's a business process, a personal routine, or a technological system, resilience comes from proactive planning, robust design, and the ability to adapt. By incorporating error handling strategies and learning from feedback, any system can become more durable and effective. Thinking in systems, understanding inputs and outputs, leveraging feedback loops, and handling errors offers powerful tools for navigating complexity. By applying these principles, you can design processes that are efficient, adaptable, and resilient in the face of challenges. Part 4, Collaborative Problem Solving. Chapter 12, Communicating with Machines. In today's interconnected world, humans and machines work together to solve problems. To collaborate effectively with machines, it is essential to understand how they think and process instructions. Unlike humans who can interpret context and infer meaning, computers follow strict logic and require precise instructions to function correctly. Miscommunication between humans and machines can lead to inefficiencies or outright failures, making clear communication a critical skill. Understanding how computers think and process instructions. Computers operate based on algorithms, step by step instructions designed to perform specific tasks. They process data in binary form, ones and zeros, and execute commands exactly as written, without interpretation. For example, when you ask a smart assistant to set a reminder, it converts your voice command into digital data, processes the instruction, and schedules the task. Any ambiguity or error in the instruction can result in an incorrect or incomplete outcome. Understanding this rigid logic helps us craft better instructions. Whether programming software or using everyday technology, recognizing the limitations of machine interpretation allows us to anticipate potential errors and improve communication. Why clear instructions are crucial. Clarity is key when interacting with machines. Consider a video game where a player must guide a character through a series of challenges. If the game's rules or controls are poorly explained, the player may become frustrated and unable to progress. Similarly, when using a smart assistant like Alexa or Siri, vague commands such as play music might result in unintended outcomes unless additional context is provided, like specifying a playlist or genre. To illustrate, imagine programming a robot to move boxes in a warehouse. A command like move the box to the left is insufficient if there are multiple boxes or unclear directions. Instead, specifying move the blue box on shelf 3 to the leftmost corner of the room ensures the robot can complete the task without confusion. These examples underscore the importance of precision and clarity when working with machines. Chapter 13, Working with Others. Effective problem solving often requires collaboration. Whether in a professional setting or personal projects, teamwork enables individuals to combine their strengths and perspectives to achieve better results. However, successful collaboration depends on clear roles, effective communication, and mutual respect. Teamwork in problem solving, roles, responsibilities, and collaboration. When working in a team, assigning roles and responsibilities ensures everyone knows their contribution to the overall goal. For instance, in a software development project, one person might focus on coding, another on testing, and another on project management. Clearly defined roles prevent duplication of effort and ensure that all aspects of the task are addressed. Collaboration also involves leveraging diverse perspectives. A multidisciplinary team, such as engineers, designers, and marketers, can approach a problem from different angles, leading to innovative solutions. However, diversity also requires strong communication to align objectives and resolve conflicts. Establishing a shared vision and using collaborative tools like project management software can streamline teamwork. Examples from project management and group decision making. In project management, frameworks like Agile emphasize collaboration and iterative progress. Teams work in short cycles or sprints, regularly reviewing their progress and adjusting plans as needed. This approach encourages open communication and flexibility, enabling teams to adapt to changes and deliver high quality results. Group decision making provides another example of collaborative problem solving. Imagine a community deciding on a new park design. Stakeholders, including residents, city planners, and architects, must work together to balance needs and priorities. By organizing meetings, gathering input, and fostering discussion, the group can arrive at a consensus that reflects diverse interests. Effective teamwork is not without challenges. Miscommunication, conflicting priorities, and unequal workloads can hinder progress. Addressing these issues requires empathy, active listening, and a commitment to shared goals. By fostering a culture of collaboration, teams can tackle complex problems with greater efficiency and creativity. Collaborative problem solving, whether with machines or humans, is a vital skill in today's world. By understanding how to communicate with machines and work effectively with others, we can navigate challenges and achieve remarkable outcomes. Part 5, Applying Computational Thinking. Chapter 14, Using Technology as a Partner. Computational thinking is not just for programmers. It is a valuable skill that enhances how we use technology in our daily lives. By understanding the principles of problem solving and logical reasoning, we can make the most of the tools available to us, transforming technology into a true partner in our endeavors. How computational thinking can help you use tools effectively. Technology is designed to simplify tasks, but its effectiveness depends on how well we use it. Computational thinking enables us to approach tools like spreadsheets, search engines, and productivity apps with clarity and purpose. For example, rather than manually sorting through data, understanding how to use formulas and filters in a spreadsheet can save hours of work. By thinking in terms of inputs, processes, and outputs, we can design solutions that are efficient and accurate. Search engines offer another case where computational thinking makes a difference. Creative Creating effective queries involves breaking down the information we need into specific keywords and logical operators. A well-structured search not only yields better results, but also reduces the time spent sifting through irrelevant information. Productivity apps such as task managers or collaboration platforms also benefit from a computational mindset. Organizing tasks by priority, automating reminders, and integrating tools with calendars are just a few ways to streamline workflows. With a clear understanding of the tools' capabilities, we can focus on achieving our goals rather than wrestling with the technology. Examples: spreadsheets, search engines, and productivity apps. Consider spreadsheets. A teacher managing student grades might use conditional formatting to highlight low scores or create a formula to calculate averages automatically. These features, rooted in computational principles, make data analysis more accessible and reliable. In the realm of search engines, a job seeker looking for remote opportunities might use Boolean operators like and, or, and not to refine their results. For instance, searching for remote and software engineer, not intern, narrows the search to relevant positions. Productivity apps offer countless opportunities for optimization. A project manager using tools like Trello or Asana can set up automated notifications, ensuring deadlines are met without constant oversight. These examples illustrate how computational thinking turns technology into a powerful ally. Chapter 15, Automating Your World. Automation is one of the most impactful ways to apply computational thinking. By identifying repetitive tasks and using technology to handle them, we free up time and mental energy for more creative and strategic activities. Even beginners can take advantage of simple tools and strategies to integrate automation into their lives. Identifying tasks that can be automated. The first step in automation is recognizing patterns in your daily activities. Ask yourself, are there tasks I repeat frequently? Could these tasks be performed by a machine or software? Common candidates for automation include sending reminders, sorting emails, managing finances, and scheduling appointments. For example, if you regularly send a meeting reminder email to your team, this task can be automated using calendar tools or email templates. Similarly, sorting incoming emails based on keywords or sender addresses can be handled by filters in your email client. Tools and strategies for beginners. Beginner-friendly tools like IFTTT, if this, then that, and Zapier make automation accessible without requiring coding skills. These platforms connect different apps and services, enabling users to create recipes or zaps that perform specific actions. For instance, you can set up a workflow to automatically save email attachments to a cloud folder or receive a text message when a weather alert is issued. For those willing to experiment with simple scripts, tools like Google Apps Script or Python offer opportunities to customize automation. A basic script could, for example, generate monthly expense reports from a spreadsheet or automatically clean up duplicate entries in a contact list. These small steps toward automation can have a big impact on productivity and organization. Chapter 16, The Future of Thinking Like a Programmer. As technology continues to evolve, the importance of computational thinking will only grow. This mindset enables us to adapt to new tools and challenges, ensuring we remain effective in an increasingly tech-driven world. Developing these skills is not just about staying current. It's about preparing for a future where problem solving and innovation are paramount. The growing importance of computational thinking in a tech-driven world. From artificial intelligence to blockchain, emerging technologies are reshaping how we work, communicate, and solve problems. Computational thinking provides a foundation for understanding and leveraging these innovations. For instance, grasping the basics of algorithms helps demystify AI applications, while familiarity with systems thinking aids in navigating complex digital ecosystems. Moreover, computational thinking fosters adaptability. As tools and platforms evolve, those who can approach new technologies logically and methodically will find it easier to learn and integrate them into their workflows. This adaptability is a key asset in a world where change is the only constant. How to continue developing these skills? Cultivating computational thinking is a lifelong process. Engaging in activities that challenge your problem solving abilities, such as puzzles, coding exercises, or strategy games, keeps your mind sharp. Reading about technological trends and experimenting with new tools also broadens your perspective. Formal education and online resources offer structured ways to enhance your skills. Platforms like Coursera, edX, and Khan Academy provide courses on topics ranging from programming basics to data analysis. Communities like GitHub and Stack Overflow allow you to collaborate with others, learning from shared projects and seek guidance. By embracing a mindset of continuous learning, you can stay ahead in an ever changing landscape. Computational thinking is not just a skill, it is a way of approaching the world, empowering you to tackle challenges with creativity and confidence. Through effective use of technology, thoughtful automation, and a commitment to growth, you can apply computational thinking to transform your personal and professional life. The journey of thinking like a programmer is not just about solving problems, it's about envisioning and creating a better future. Conclusion. You are a computational thinker. Congratulations! By exploring the concepts and strategies in this book, you have taken significant steps toward adopting a computational mindset. Whether or not you write code, thinking like a programmer is a skill that transcends technology, offering powerful tools to navigate complexity, solve problems, and innovate in your personal and professional life. Recap of the journey. We began by uncovering the foundational principles of computational thinking. Understanding how to break down problems, think logically, and iterate through solutions provided a framework for tackling challenges systematically. From there, we delved into the tools and strategies that programmers use, such as decomposition, sequencing, and algorithms, showing how these techniques apply to everyday situations. Next, we explored the power of systems thinking, learning to analyze inputs and outputs, harness feedback loops, and build resilience through error handling. Collaborative problem solving highlighted the importance of clear communication, whether with machines or people, and the value of teamwork in achieving shared goals. Finally, we turned our focus to applying these principles in practical ways. By using technology effectively, automating repetitive tasks, and embracing lifelong learning, we equipped ourselves for a future where computational thinking will play an increasingly vital role. Encouragement to apply these principles in everyday life. The true value of computational thinking lies in its versatility. You can use it to optimize your daily routines, make better decisions, and approach challenges with confidence and creativity. For example, apply decomposition to break a daunting project into manageable steps. Use abstraction to focus on the big picture and avoid getting bogged down in unnecessary details. Recognize patterns to streamline repetitive tasks or spot trends in data. Moreover, don't hesitate to share what you've learned with others. Whether teaching a child how to organize their homework or collaborating with colleagues on a complex project, these principles can inspire and empower those around you. Resources for further learning. Your journey as a computational thinker doesn't end here. Countless resources are available to deepen your understanding and refine your skills. Here are some recommendations to continue learning. Online courses. Platforms like Coursera, edX, and Khan Academy offer courses on programming, problem solving, and data analysis. Books. Explore titles such as The Pragmatic Programmer by Andrew Hunt and David Thomas, or Algorithms to Live by Brian Christian and Tom Griffiths for deeper insights. Communities. Join forums like Stack Overflow, Reddit's r/programming, or local coding meetups to exchange ideas and seek advice. Practice. Engage with platforms like LeetCode, Code Wars, or Scratch to challenge yourself with real world problems and projects. By continuing to learn and apply computational thinking, you will remain adaptable and capable in a rapidly changing world. Embrace the mindset of a lifelong learner and let the principles you've discovered guide you towards success. In conclusion, you are now equipped to think like a computational thinker. Use these tools not just to solve problems, but to envision and create a brighter, more efficient future. The journey is ongoing and the possibilities are endless. Keep exploring, keep experimenting, and keep thinking like a programmer. I'm Justin, and I hope you've enjoyed this content. You can reach out to me at automateofficework.com. You can book a call with me or find me on LinkedIn or email me at justin@automateofficework.com. And with that, I wish you happy automating.